The only difference with question 8 here from exercise 6C is that it says something in terms of vectors. So it says a particle P is projected from the origin with velocity 12I plus 24J meters per second, where I and J are the horizontal and vertical units, as you would expect. The particle moves freely under gravity. Find A, the position vector of P after 3 seconds, and then B, the speed of P after 3 seconds. So this is a nice one because it's going to link to some things we've already done in vectors as well. But when we go back to vectors for the final chapter of mechanics, I will do some more on this to be even more explicit about it, okay? So if something has an initial velocity that it's been projected with 1224, I don't actually really need to even do the sine and cos part of it, because they've already told me it's going 12 and 24. They've already told me how it's moving. And I know that the particle is going to be doing whatever kind of pathway that we think it's going to do from here. And we need to find out the position vector. Now, probably the thing that might have put some of you off is it asks for the position vector. But this is the origin that it's being projected from. So that's got a position vector of 0, 0. All it's asking is, where is the particle after 3 seconds? That's what it's saying. The position vector of P after 3 seconds is just saying, where is it? So we're going to consider the motion in a couple of different ways. This diagram I've drawn here is unnecessarily large. And now I'm going to shrink it badly. So first of all, I would consider the horizontal motion, because I can tell the horizontal speed is 12 and the time is 3. So speed is 12, time is 3. So the distance that it goes horizontally is equal to speed times time, which is 36. We'll then look at the vertical motion. Well, I know it's after 3 seconds. I'm going to consider upwards as positive. So its initial speed upwards is 24. The acceleration is minus 9.8. What am I interested in for the position? What other letter am I interested in? S. I'm trying to find out where it is. So we know that S equals ut plus a half a t squared. So you get a position of where it is. Anyone got that? So save me typing it in. How much? 27.4. 27.4 meters. So the position vector of where it is, well, horizontally, it's gone 36 meters along. And vertically, it's gone 27.4 meters up. 27.9. 27.9. And that's it. A position vector is just written, where is it horizontally, where is it vertically? Now, what we will see in the future is you could have done this whole thing using vectors. We could have said S equals ut plus a half a t squared, and you can do a vector version of this formula that you have. And the only thing that you would need to know, this is what we're going to do later on in mechanics, is we could have just said the position vector is equal to u is 1224, t is 3. The acceleration, well, it's going to be plus a half. The acceleration is going to be 0 in the horizontal direction and 9.8 downwards, and you're multiplying it by 3 squared. Don't worry if you don't get this now, because we're going to do this again when we come to vectors. And you can just do the whole calculation all at once. So you get 36 and 72. And then here you get plus a half times 0 times 9 is 0. A half times minus 9.8 times 3 squared is minus 44.1. And when you add those together, you get 36 and 27.9. So the whole thing can be done all at once when you do it with vectors. In the past, some students liked doing it as the whole thing. Some people didn't like doing it. You can do it and just separate it into different things that you've got here. Like I said, I wasn't expecting you to know how to do it this way. You can just do it this way. But we're going to come back to this idea when we look at vectors. The reason it works like this is because the acceleration in the horizontal direction is 0. That's what we discussed in the last lesson. So actually this s equals ut plus a half at squared. Horizontally, it just becomes s equals ut, which is distance equals speed times time. So that's actually what that formula is doing. For horizontally, it's just got a 0 there, and it comes straight to that bit. Now, the second part, maybe there are some different things we need to do here. So we want to find out the speed of p after 3 seconds. Well, what's the horizontal speed of p after 3 seconds? Yeah, the horizontal speed is 12, because it's constant. So we're going to think about what the vertical speed is. Well, we know that if we're taking up as positive, u was 24, a was minus 9.8, and t was 3, and we're trying to find out what v is. Well, we know that v equals u plus at, so it's 24 minus 9.8 times 3. So 24 minus 9.8 times 3 is minus 5.4. So all you need to do to find out what the speed is after 3 seconds, well, it's moving across with 12, and the minus 5.4 says that it's moving downwards with 5.4. But that's what the velocity is. The velocity is 12 minus 5.4. I don't want that. I want the speed. So what do I do for the speed? I Pythagorize. So I just do your 12 squared plus your 5.4 squared. And you get whatever you get. Yeah? 13.2, actually, to 3 significant figures. OK? And you also could work out the angle that it was as well by using everything we know to do with vectors. So which point on the journey is it after 3 seconds, do we say?
27.9.
Yeah, but which point, if you were to describe on what part of the shape it is, and you should be able to tell me. It's on the right-hand side because it's going across, but it's also got a downwards part of motion. Here it's travelling up. Here it's travelling down. So after 3 seconds, it's probably somewhere here where it's going across 12 and down 5.4. Overall, it looks like it's going in that direction that we've got there. And this example is great because it perfectly leads on to a couple of examples that I wanted to have a look at, which goes back to your booklets. So if you grab your projectiles booklets, does anybody not have one of these? Do you need one, Masuma? So we're actually going to be doing a speed at a given point. You two need one, yeah? So it leads really nicely onto this kind of question where it's talking about finding a speed at a given point. And there'll be a bit of recapping of some of the previous things that we've done earlier on, and then there's some new stuff as well. I guess it's kind of similar to what we've just done though. So this one, it says finding speed at a given point. In this question, use g equals 10 meters per second. So make sure, if they don't tell you what g is 9.8, but they often like to say that g is 10. Don't then use a different value. You have to use 10 if they tell you to. An object is projected with speed u meters per second from a point A at the top of the vertical building. The point A is 25 meters above the ground. The object is projected at an angle alpha above the horizontal, just like it looks like in the diagram, with tan alpha equals 5/12. The object hits the ground at the point B, which is at a horizontal distance of 42 meters from the foot or from the base of the building, as shown in the diagram. The object is modelled as a particle moving freely under gravity. Particle meaning we can... What's the modelling of particle? Ignore air resistance, okay? These are always going to be 1 or 2 mark questions in the exam. I'm constantly asking you about them, so you hopefully will just remember them here. We need to find out what the value of u is, then the time taken for the object to travel from A to B, and then the speed of the object when it is 12.4 meters above the ground, giving your answer to 2 significant figures. So I think this beginning part, A and B are pretty familiar, and C is reminiscent of what we've just been talking about on that vectors question that we looked at. So what do you think is a good thing to get started? Anybody got a starting point for this?
Would you resolve?
Yep, okay, so I'm going to have here, I'll have a u cos alpha and a u sine alpha. What is sine alpha? 5 over 13, and cos alpha is 12 over 13. So you may like to rewrite these and say that this is 12 over 13u and 5 over 13u like this. Any suggestions of what is going to be better to think about, the horizontal or the vertical? Yep, the vertical is going to be the best one to look at here because we've got more information about it. Vertical motion, do we want up positive or down positive?
Up, negative.
Okay, which one? Up as positive. You said up as negative.
Wait, what?
What do you want to do? I don't mind.
Up would be negative, wouldn't it?
Okay, fine. But it doesn't matter. But I was asking you which one do you want to do. So it sounds like we're doing down as positive. What's S then? No, we've said down is positive. So S is 25. Okay. A is 9.8. U is minus 5 over 13. U. And what do we want to find out? We want to find out T. Because that is the most important value that will bridge you between the two things, okay? So it's that same old equation, S equals ut plus a half at squared. Oh, I've even made a mistake here. No one told me. Why didn't anyone tell me that? I can't do everything, it's too much. So I get 25 equals minus 5 over 13 ut plus 5 t squared. Maybe vertical wasn't the best one to start with because we've now got an equation with a couple of unknowns here. So maybe we should look at horizontal and then put them back together. No harm if we do them in two different ways.
That's when t equals, that's when we're looking at t equals 0.
That's not when we're looking at t equals 0. We're going to do simultaneous equations, yeah. So we'll look at horizontal motion. The speed is 12 over 13u. And the distance is 42. And the time is t. What can you tell me about this time and this time? The same. Because they're at the same point, the same place over here, okay? So we actually do have simultaneous equations because we know that time is equal to distance over speed. Now, if you don't like doing fractions within fractions like this, you could do distance divided by 12 over 13u. But the biggest mistake people make here is they don't think that the u is actually the u is actually belonging with the 12 in terms of the multiplication. So when you take the reciprocal, the u is going to go to the bottom. I probably think about it like this though. I would look at this fraction and I would multiply the top and bottom by 13 or just do 42 divided by 12 over 13 and knowing that the u is going to be on the bottom because it's already on the bottom. And what does that simplify to? 91 over 2, so it's 91 over 2u. Yeah? Then we know that t is equal to this. It makes sense that the u is on the denominator, guys. The u has to be on the denominator because we were dividing by speed. I've seen people do this before where suddenly u jumps up to the top. You've got to be really, really careful with this. So you get 91 over 2u. Well, that means we can come back over here. Where's the page extender gone? And we can substitute this into here. So 25 equals minus 5 over 13 u multiplied by 91 over 2u plus 5 times this thing squared. And now we're happy with that. because it's just an equation with one unknown in it. So I'll give you a chance just to write some of this down. Yeah, it's kind of hot in here, isn't it? So should we start simplifying this? What happens over here? The u's cancel out, and when you do 5 over 13 times 91 over 2, you get minus 35 over 2. And then in here, oh, not an equals. Make sure you square this correctly. So you've got 91 squared times 5 divided by 4. Seems a bit of a mess. 41405 over 4u squared. That's what I've got.
We get some low values.
So to solve this equation, we can add this to the other side. So you've got 25 plus 35 over 2. Let's go into numbers now. 42.5 equals 41405 over 4u squared. Is this not making much sense when it works out? And then we'll multiply up. So you get 170u squared equals 41405. So u squared is equal to, did I type that in? 41405 divided by 170 is equal to 243.55, blah, blah, blah. So u is the square root of that, which is 15.6 meters per second to 3 significant figures. So it's quite involved, that question. This is probably the type of stuff you'd expect to see in like an exam kind of style, where there's two things that are unknown. There's the speed and the time. But like I said previously, the time was that bridging value that took you between those two things, and you're allowed to do those simultaneous equations to produce that kind of result that we came up with. And so then part B of the question should be quite quick. We want to find out the time that it takes. So what's that asking for me? Good, just substitute u back into one of these values for t. So t is going to be equal to 91 over 2 times 15.606, blah, blah, blah. So let's times that by 2. 91 divided by the answer, and we get that the time is 2.92 seconds to 3 significant figures. Just going to double check that that was right. Yep. But part C is the thing that's kind of different. I like to show the part A and B here because it's a big simultaneous equations question, where you're going to be putting one of the things into the other to figure out how to solve this. Always comes up with some kind of quadratic-y type of thing that we've got there. Now part C is a return to what we spoke about on that previous slide. It says the speed of the object. We want to find the speed of the object when it is 12.4 meters above the ground. So let's have a think about that. We want to find the speed when 12.4 meters above the ground. Well, morning. It's horizontal speed. We know from earlier on, the horizontal speed is 12 over 13u. And u was 15.606, blah, blah, blah. So I'm going to do that by 12 over 13. And we get 14.40588, okay? And we know that this speed here is constant. It's not going to change. So that's one of the aspects of that triangle that we're going to have. What we need to work out, though, is the vertical speed. And to work out the vertical speed, we're going to use the fact that the time is 1.2 seconds. Remember, that's the time that they want us to, oh, not 1.2 seconds, is it? Where have I got 1.2 from? That was the previous thing. Ignore me, ignore me. If we're going to be considering it downwards, we know that the acceleration is 10. We need to find out what its initial speed is. Is the distance going to be 12.4?
Yes.
No. It's going to be 12.6 because they want to know when it is 12.4 meters above the ground. And actually, that is 12.6 meters from where it started. So in terms of its displacement, if we want to know when it's 12.4 meters above the ground, from here to here, its displacement is 12.6. So that's a little trick and a twist in that question, that actually the displacement is 12.6 downwards. We're trying to find out what v is. And its initial speed, is it positive or negative, its initial speed in this case? No, its initial speed is negative. We've said that down is positive. Pardon? We've taken the downwards as positive, which I've written here, because we've said that the acceleration is positive and the displacement is also positive. So the value of u, was it 5/13? Yeah, 5/13 of u. So it will be minus 5/13 of 15.606.
Downwards positive, the ball is projected upwards. So u is negative.
So you get minus 6.002. Okay? Now we just need to put this all together by doing v squared equals u squared plus 2as. So it becomes minus 6.002 squared plus 2 times 10 times 12.6. So you get v squared is 288.03 blah blah blah, or 0294 blah blah blah. Now we could square root that, and we get that v is 16.97. But in a minute we're going to have to square it. We also don't know, is v going to be positive or is v going to be negative? Well, if we have a look at the diagram, what do you think the value of v should be, the positive or the negative one?
Positive.
It should be the positive, because over here we know it's moving across and it's moving downwards, so we should expect it to be a positive value, because we've said in this question that downwards is positive. So actually we would take the positive value when we did the square root that we have there. Now we know that the horizontal speed is this. We now know that the vertical speed is this. So putting this together to find the overall speed, we know it's going 14.405 blah 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 along. We know it's going 16.97 downwards. So the speed that we have here, v, would be equal to the square root of the 14.405 squared plus the 16.97 squared, all square rooted. And when you square root that, we get that v is 22.260. But you know what? We've done so much rounding here. I'm just going to go with two significant figures. Oh, I mean, I haven't done much rounding, but if you have done lots of rounding, I would just round it to two significant figures and write two significant figures at the end. Yes? Why? What's the answer in the back? 17.
The answer in the back is wrong.
I think the answer in the back is wrong because what they've done is they've found the speed just here. They've just done that. So actually it's a good job I didn't set you to do that one for homework because it's definitely wrong. So this is the new part that we've got, right? That if you're trying to find the speed at a particular point, the horizontal speed is given to you. All you need to do is find the vertical speed and Pythagorize. Okay, that's what you need to be able to do for that next part of it. You just need to put them back together, Pythagorizing them, knowing that the horizontal speed hasn't changed at all. And the horizontal speed will never, ever change for these kinds of things that you've got. I think another tricky part of this question was that S was equal to 12.6 rather than 12.4 because it said 12.4 meters above the ground. At some point when you do a mock exam, there's going to be a question like this, and they do the same thing about a cliff and the sea, and they say, what's the speed of it when it was 5 meters above the sea? You're tempted to say the displacement is 5, but actually the displacement is from the top of the cliff all the way down to that point. They love to do anything that is annoying. So anything that's annoying, they will be doing it for sure. What you've got next in your booklet for you to have a go at, and I'll leave this on the board for you to finish writing, is you've got this question here, which also has got a bit about finding the speed of the ball at a particular point. And then I think you've also got an exam question here as well that's also got something about finding some speeds as well and some other tricky kinds of bits that we've got. And then we're going to move on to making it more abstract as well. This is going to be the last lesson. It's just a 2-lesson topic. We're done on projectiles after this. It's short, but it's pretty challenging, I think. So I'll leave it on this bottom half of the page, and then we'll go from there. I think we should probably get up.